We're going to go ahead and factor the following problem. So notice there are 4 terms. Typically when you see 4 terms, we try to do our grouping method. However, and I'll go ahead and just go through it. If you try grouping, you pull out your greatest common factor of x squared. For the first pair, you end up with 2x plus 5. Greatest common factor of the second pair is 1, which means you'll end up with 7x minus 5. These do not match up, so I can't pull out another greatest common factor to finish grouping method. So for that reason, grouping method fails, and when any other technique fails, including grouping method, we actually turn to synthetic division factoring. So synthetic division factoring, we are going to turn to some of the skills I taught in lesson 3.2. So first skill be finding our potential zeros. So in this problem, to find our potential zeros, I'll take the factors of 5, so 1 and 5, and we'll divide them by the factors of 2, 1 and 2. So we know we have a possibility of having a positive negative 1, positive negative 5, positive negative 1 over 2, and positive negative 5 over 2. So I'm dividing each number by 1 and then each number by 2. Now, we could use Descartes' rule of signs to figure out maybe if we know for sure one of the values is the positive or negative. So I might try Descartes' rule of signs. So notice this is positive, positive, and negative. Well, I know for sure there has to be at least one real zero. And so, one real positive zero. That's important, since we were just doing the positive. For that reason, if you want, you can just automatically look at just the positive numbers on this list and just try them out. So for instance, I might try 1, so plug 1 in. -5. Well, the nice thing about when plugging 1 in is really you're just adding the coefficients together. And I can automatically tell that that's not going to equal 0, because 5 and a negative 5 will cancel out, and otherwise you're just adding 2 positive numbers. So we get 9. So this one did not work. One did not work. So I could go on to 5, I could go on and so on. But what you're going to find is when I plug 1/2 in, it ends up working. Okay, so x equals 1/2 is the one I want. I know it works because when I plug it in for x, I get 0. So for that reason, I'm going to put 1/2 in my box. That's my 0. And then I'm going to go ahead and do my synthetic division. I'll set up my synthetic. So I'll have 2, 5, 7, and negative 5. And then I'm going to go ahead and just work my magic. Do my synthetic divisions. Drop down that 2. 2 times 1/2 is 1. Add 5 and 1, you get 6. 6 times 1/2 is 3. 7 plus 3 is 10. 10 times 1/2 is 5. And then we get a remainder of 0, which is what we wanted. Now, since we are factoring, this 0 needs to be written as one of the factors. Okay, so I get a 0 of 1/2. Well, that means since we were doing synthetic division, we had x minus 1/2. In synthetic, you always use x plus the number or x minus the number. And since it was a 0, you do the opposite. 2, 6, and 10 would be written as 2x squared plus 6x plus 10. That's because, remember, we go down by 1x when it was originally to the third, but we divided by x minus 1/2. So we're dividing everything by x, which means x cubed now will become x squared. So we have to finish up our factoring. So there's a greatest common factor, 2. So I'm going to put that 2 in front of everything. X minus 1/2. This would be x squared plus 3x plus 5. Well, x squared plus 3x plus 5 is a quadratic, so we try finding factors of 5 that add up to 3. Well, there aren't any. The only factors of 5 are 5 and 1. Those add up to 6. So one last thing, whenever I tell you to factor completely, I mean over the integers. 1/2 is not an integer, but we can fix that with this greatest common factor we found by just distributing that back in. So this would end up being 2x minus 1, and then x squared plus 3x plus 5. Oops, not 3x squared, 3x plus 5. And that would be your final answer.